Welcome back, legends. In this long-form Budfellas educational deep dive, we're exploring one of the most misunderstood aspects of plant life: how plants recover from stress. Many people focus on what causes stress, but far fewer understand what happens after stress has occurred. Recovery is not instant, visible, or simple. It is a slow, complex biological process that happens quietly inside the plant long before outward signs appear. This episode is purely educational. We are not giving instructions or fixes. Instead, we are explaining the internal mechanisms that allow cannabis plants to regain balance after challenging conditions. When recovery is understood as biology rather than magic, plant behavior becomes far easier to interpret. Before we jump in, remember, this channel is for viewers over 18, and our content is purely educational. We're not here to promote or encourage illegal activity. In the UK, cannabis cultivation remains illegal without a license. What we are doing is learning plant science and helping beginners avoid common mistakes. Quick update. We've just launched the Budfellas Telegram community, connecting growers and enthusiasts from around the world. It's legal-focused, all about networking, plant science, and shared experience. Links in the description. Stress in plants is a state of imbalance. It occurs when environmental demands exceed the plant's current capacity to respond. This can involve temperature shifts, moisture changes, light intensity fluctuations, or internal resource shortages. When stress occurs, the plant shifts priorities. Growth slows. Energy is redirected. Protective systems activate. Recovery begins the moment stress signals reduce. But recovery is not a switch that flips. It is a gradual rebalancing of internal systems that were pushed out of their optimal operating ranges. One of the first steps in recovery is the stabilization of cellular energy production. During stress, respiration and photosynthesis often become unbalanced. Once conditions normalize, enzyme systems slowly regain efficiency. Sugar production and energy transport return toward equilibrium. This restoration is essential before growth can resume normally. Another key part of recovery is repairing cellular damage. Stress often creates reactive oxygen species inside cells. These molecules can damage proteins, membranes, and DNA. Plants activate antioxidant systems to neutralize these molecules. Over time, damaged cellular components are replaced. This repair work consumes energy and resources. Water balance is also re-established during recovery. During stress, stomata may close, transpiration may slow, and internal water pressure may change. As conditions stabilize, stomata reopen gradually. Transpiration patterns return to normal. This restores nutrient flow from roots to leaves and growing tissue. Hormonal balance plays a central role in recovery. Stress hormones such as abscisic acid rise during challenging conditions. These hormones reduce growth and conserve resources. When stress ends, hormone ratios shift again. Growth-promoting hormones gradually increase. This hormonal rebalancing allows developmental processes to restart. Root systems are often heavily affected by stress. Recovery involves restoring root respiration, nutrient absorption, and microbial partnerships. Root tips resume cell division. Damaged root hairs are replaced. As root function improves, signals are sent upward to support renewed growth. Leaves also undergo recovery. Damaged leaf tissue may not fully repair, but surrounding healthy tissue increases photosynthetic output to compensate. New leaves may form with improved structure. Leaf posture often normalizes as internal water pressure stabilizes. One important aspect of recovery is prioritization. Plants do not restore everything at once. Essential survival systems recover first. Growth systems recover later. Reproductive investment may resume only after stability is sensed over time. This staged recovery ensures energy is used efficiently. Another key feature of plant recovery is memory. Plants remember stress through chemical and genetic markers. This memory can alter future responses. Some plants become more tolerant to similar stress after experiencing it once. This is known as stress priming. However, Stress memory also means recovery is not always complete. Previous stress can leave long-term imprints on growth patterns, developmental timing, and energy allocation. This is why early stress can influence final outcomes much later. Recovery also involves recalibrating internal clocks. Circadian rhythms can be disrupted by stress. Once conditions normalize, internal timing systems gradually resynchronize with environmental cycles. Proper timing is essential for balanced metabolism. Another important part of recovery is restoring membrane stability. Stress can make cell membranes too rigid or too fluid. During recovery, lipid composition is adjusted to return membranes to optimal flexibility. This stabilizes transport of molecules and signals between cells. Protein systems also undergo recovery. Heat shock proteins and repair enzymes help refold or replace damaged proteins. Once protein balance is restored, normal metabolic flow resumes. Microbial communities around roots also shift during recovery. Beneficial microbes recolonize the root zone as conditions improve. This restores nutrient cycling and chemical signaling in the rhizosphere. It is important to understand that recovery takes time. Visible improvement may lag behind internal recovery by days or weeks. Conversely, visible symptoms may persist even after internal systems have stabilized. This delay often leads to misinterpretation. Recovery is also influenced by the severity and duration of stress. Short, mild stress may require little recovery. Prolonged or repeated stress demands extensive repair. There are limits to how much recovery is possible. Another key point is that plants recover through adaptation, not reversal. They do not return to a previous exact state. Instead, they build a new balanced state based on current conditions and stress history. This adaptive recovery explains why plants may look or behave slightly differently after stress has passed. They are not broken, they have recalibrated. From a biological perspective, recovery is a demonstration of resilience. It reflects the plant's ability to manage energy, repair damage, rebalance signals, and resume coordinated function. Understanding recovery changes how we view plant behavior. Rather than expecting instant responses, we recognize the hidden timeline of healing. In summary, plants recover from stress by restoring energy balance, repairing cellular damage, rebalancing water flow, resetting hormone systems, regenerating roots and leaves, recalibrating internal clocks, rebuilding microbial partnerships, and adapting future responses. This process is slow, layered, and intelligent. Big, healthy growth following stress is not luck. It is evidence of a plant that has quietly completed a complex internal repair program. Thanks for tuning in, legends. If you enjoy calm, science-based explanations of cannabis behavior, stay locked in. This is Budfellas Educational, Evergreen, and always within the guidelines, signing out.